Hi students, how are you? Welcome back to our beautiful channel Chem High. So today we are going to solve some problems related to Faraday's laws, Faraday's first law and Faraday's second law. Nothing but problems related to electrolysis. So to solve these problems, so what are the different formulae required? Anyhow, in last video we learned Faraday's first law mathematical expression and Faraday's second law. So what are the different formulae required? So based on that Faraday's first law, calculate the amount of substance deposited, liberated, like this they will ask. So how to calculate this amount of substance deposited? W is equal to equivalent mass of that element into I into T by 96,500. Okay, this is one formula to find the mass of substance deposited or ions discharged. Okay, E into I into T by 96,500. Here E is equivalent mass, I is current in amperes, and T time in seconds. Just all they will mention. Just we have to find the mass of the substance. Okay. And next Faraday's second law. What is the Faraday's second law? Mass of the substance. If same quantity of, in problem, same quantity of electricity passed, like this given, same quantity of electricity passed, then that is a problem related to Faraday's second law. So now here mass directly proportional to that equivalent mass. So what we are using formula? W1 by W2 is equal to E1 by E2. Okay. Problems based on this formula. W1 by W2 is equal to E1 by E2. Here Faraday's first law, the amount of substance formed, that is a product obtained, that is directly proportional to quantity of electricity used. If same quantity of electricity used, the amount of substance formed, that is directly proportional to its equivalent mass. Okay. Faraday's first law expression and Faraday's second law. And next, some small hints to solve the problems. 1 Faraday. 1 Faraday nothing but there is a 96,500 coulombs. Okay, 1 Faraday means 1 mole electrons. Okay, in problems related to electrons like that, any problem given, 1 Faraday 1 mole electron, and 1 Faraday means there is a 1 mole electron. It is equal to 1 gram equivalent of any substance. 1 gram equivalent of any substance. 1 Faraday electricity passed. How much substance we are getting means 1 gram equivalent of substance. That is any 1 gram equivalent of substance. For example, 1 Faraday electricity is passed through silver nitrate solution. How much amount of silver deposited at cathode or anode? Silver metal at cathode. How much amount of silver deposited? Like this problem given. 1 Faraday, 1 gram equivalent. 1 gram equivalent of silver means atomic mass by silver. Ag plus atomic mass by 1. So what is its equivalent mass? 108 grams. Okay, 108 grams of silver. 1 Faraday of electricity if passed, then how much amount of silver will deposit given there is a 108 grams of silver. Like that 1 Faraday passed, how much amount of copper will deposit, because these are repeated. In many problems these are repeated values, so nothing but silver, copper, hydrogen, like this only they will repeat. That's why at least these atomic numbers, atomic masses we know, we can solve problems easily. Anyhow in problem, in bracket they will mention atomic mass. Okay. So here 1 Faraday electricity passed, then how much amount of silver will deposit? 108 grams of silver. Like that how much amount of copper will deposit? Its equivalent mass, because 1 Faraday always 1 gram equivalent only. So what is the equivalent mass of copper? Copper means there is a Cu plus 2 to Cu. So by 2, atomic mass 63.5. 63.5 by 2, it is equal to, okay, 31.7. So roughly we can use this 31.7 grams of copper. And 1 Faraday, how much aluminium? How many grams of aluminium? Grams of aluminium. Aluminium is that we are getting from Al plus 3 to Al. Al plus 3 to Al. Aluminium atomic mass 27 grams. Equivalent mass, because 1 Faraday gives 1 equivalent only. 1 Faraday produces 1 equivalent of any substance. 1 equivalent of silver, nothing but 108 grams of silver. 1 equivalent of copper, nothing but 31.7 grams of copper. 1 equivalent of aluminium, nothing but how much equivalent mass? 27 by charge 3, nothing but 9 grams. 9 grams of grams already I written here. 9 grams of aluminium. Okay, 9 grams of aluminium, 1 Faraday. Like that, 1 Faraday releases how much hydrogen? Now hydrogen gas in liters they will mention, or in ml. How much liters of hydrogen? Now see this. Hydrogen. To release H plus, here H2. We are using H plus. H plus changes to H2. At cathode, H plus changes to H2. So balance this 2H plus. 2H plus changes to H2 means how many electrons? 2 electrons. 2 electrons. 2 electrons means 2 Faradays. 2 Faradays electricity is passed. Then how much hydrogen we are getting? 2 Faradays electricity passed. 1 mole H2. 1 mole H2 means how much? 22.4 liters. 22.4 liters. 1 Faraday. 2 Faradays 22.4 liters. 1 Faraday 11.2 liters. So 1 equivalent of hydrogen. 1 equivalent of hydrogen means 11.2 liters of H2. Okay, 1 equivalent of hydrogen. Nothing but that is a 11.2 liters of H2. And 1 Faraday produces how much oxygen? Now see that oxygen O2 formation from 2 oxygen charge minus 2 O2 minus ions combined changes to O2. Nothing but loses how many electrons? Each oxygen loses 2 electrons. Then 2 oxygens 4 electrons. 2 oxygens 4 electrons. Nothing but O2 minus changes to O2 by losing 4 electrons. Nothing but 4 Faradays. 4 Faradays releases how much? 1 mole oxygen 22.4 liters. 4 Faradays 22.4 liters. 1 Faraday 22.4 by 4, 5.6. Okay, first you practice this, then any problem given by using this relation we can solve easily. So what is that? 1 Faraday, nothing but 1 mole electron. 1 mole electron means it produces 1 gram equivalent of any substance. Anyhow, repeated in problems, repeated examples: copper, silver, aluminium, hydrogen, oxygen. 1 Faraday gives 1 equivalent of copper, nothing but 31.7 grams of copper. 1 equivalent of silver, 108 grams of silver. 1 equivalent of aluminium, 9 grams of aluminium. 1 equivalent of hydrogen, nothing but 11.2 liters of hydrogen. 1 Faraday releases 11.2 liters. Problem how they will ask. 22.4 liters of hydrogen released when electricity is passed. How much copper will deposit in same quantity of electricity passed? Nothing but Faraday's second law. So 22.4 liters of hydrogen we are getting. Same electricity is passed. How much copper will get? Like this given. So 11.2 liters means that is a 1 Faraday. 22.4 liters means 2 Faradays. 2 Faradays passed. How much copper getting? 1 Faraday gives 31.7. 2 Faradays gives 63.5. So without using pen and paper we can solve the problems. Okay. So 1 Faraday 11.2 liters of hydrogen. Like that 1 Faraday 5.6 liters of oxygen. Okay. And next. Other hints. Here related to Faradays. Now sometimes they will ask work in joules. Okay, 1 joule that is equal to 1 watt or just joule. Watt into time in seconds. So joule means watt second. Okay, what is this? Power in watts. Okay, power in watts. This is power and it is the time. Okay, power in watts into time in seconds. Power means what is this value? Voltage in volts. Voltage in volts into current in amperes. Current in amperes. Power means voltage into current in amperes into T. I into T means what is that? Coulomb electricity. So V into Q. So calculate the work in joules. Like this any problem given, joules is equal to V into Q. Nothing but they will give volts and also quantity of electricity passed. We can calculate it joules. Okay, this is a joule conversion. Next. This much mass deposited, how much surface area covered? Like this surface area covered also they will ask. So mass is equal to volume into density. Okay, volume into density. Volume is here surface area covered into thickness. Surface area covered into thickness into density. Okay. So this much mass deposited, how much thickness or how much area covered like this type of problem, surface area covered. This type of problems given, use this relation. Mass is equal to area covered, surface area covered into thickness into density. Okay. So now come to the problems. These are the different relations. Now the first problem. See this first problem. 1 Faraday of electricity is passed through 10 liters of a solution of aqueous solution of NaCl. 10 liters solution of aqueous solution of NaCl. Calculate the pH of the solution. Calculate the pH of the solution. So pH calculation nothing but related to electrolysis. So here aqueous NaCl solution, not fused, aqueous NaCl solution or electrolysis. Anyhow, in last video we learned what are the products obtained, that's acidic nature, basic nature, how to identify. NaCl, Na plus and Cl minus. Aqueous means here H2O, it decomposes to H plus and OH minus. Competition between these cations and anions. Cations migrates towards the cathode. At cathode, Na plus and H plus. Based on these reduction potential values, which one has more reduction potential value? That reduces. Which one reduces here? H plus reduces. So H plus reduces, nothing but gain electron. It changes to H2 gas. It changes to H2 gas. And at anode, Cl minus and OH minus both are there. Based on their over voltage, the reason is over voltage, OH minus not undergoes Cl minus involved in oxidation, because this one requires more voltage, that is called over voltage of OH minus. Now Cl minus, it changes to Cl2 and 2 electrons. Okay, like this happen. So hydrogen released at cathode and chlorine released at anode. Then what is the remaining? Here Na plus and here OH minus. Na plus and OH minus. Nothing but these two combined changes to sodium hydroxide NaOH. Anyhow, OH minus ions are there. Nothing but it is the basic in nature or acidic in nature. This is basic in nature. So here it is basic in nature. Now how to calculate this pH? How much OH minus is present? Now what is the relation? 1 Faraday. Nothing but 1 mole electrons. 1 mole electron means 1 gram equivalent of any substance. 1 gram equivalent of any substance. So in this problem, 1 Faraday gives 1 gram equivalent of hydrogen at cathode. Okay, and it gives 1 gram equivalent of chlorine at anode. And it gives 1 gram equivalent of Na plus ions. Na plus not changed to sodium hydroxide formed. And it gives 1 gram equivalent of OH minus. But these two combined changes to 1 gram equivalent of NaOH. So 1 Faraday passed 1 gram equivalent H2, 1 gram equivalent Cl2, 1 gram equivalent of Na plus, 1 gram equivalent of OH minus. 1 Faraday always 1 gram equivalent of substance deposit or liberate. Now, how many Faradays passed, that we should check. This is the relation. 1 Faraday gives like this. Now, how many Faradays? 1 Faraday only we are passing. 1 Faraday pass means how much OH minus? 1 gram equivalent of OH minus. 1 gram equivalent. Number of gram equivalents. That is 1. Now, what is the normality? Nothing but concentration of OH minus. Normality is equal to number of gram equivalents by volume. Normality formula. Molarity is equal to number of moles by volume in liters. Normality is equal to number of gram equivalents by volume in liter. How many gram equivalents? 1. By volume, how much given? 10 liters. 1 by 10. Nothing but what is the normality? 0.1. So the constant normality nothing but concentration of OH minus 0.1. So what they are asking? Just a very simple relation. 1 Faraday equal to 1 gram equivalent of what we are getting during this electrolysis. First observe that we are getting hydrogen, chlorine, Na plus and OH minus. All these 1 gram equivalent we are getting. Now how many Faradays passed? Observe. 1 Faraday only. So how much we are getting? 1 gram equivalent of OH minus. Okay. Now normality we need, because we want to calculate pH here. So how to find? We need concentration. So concentration means normality. What is the formula? Normality is equal to number of gram equivalents by volume in liters. So 1 by 10, 0.1. This is the concentration of OH minus. So first calculate POH, because given is OH minus concentration. POH is equal to minus log base 10 OH minus concentration. Yes or no? So now it is equal to minus log base 10 0.1. 0.1 means that is the 10 power minus 1. So minus log base 10 10 power minus 1. Log A power n log A. Now it is equal to 1 log 10 1. Log 10 value 1. 1 into 1 1. So POH how much we are getting? 1. If POH is 1, EOH 1. Then problem is pH. pH is equal to 14 minus POH. Yes or no? 14 minus 1. So what is the answer? 13. So what is the pH of this solution? After this electrolysis, if 1 Faraday electricity passed, then what is the pH of 13? So here it is a basic in nature. Okay. Better one more problem like this. So see the second problem. Second problem. A current strength of 96.5 amperes is passed for 10 seconds. Okay. I given, T given, through 1 liter of a solution of 0.1 m copper sulfate. Calculate the pH of the solution. Again pH calculation. So how to solve this one? What they given here? What is the relation? 1 Faraday. 1 Faraday gives. Now what is the given solution? Copper sulfate. First we should observe OH minus we are getting, or H plus, or neither H plus nor OH minus, nothing but neutral solution. Okay. Copper sulfate, aqueous solution. Through a solution of copper sulfate, definitely pH they are asking means it is an aqueous solution. In this aqueous solution, copper deposited at cathode or hydrogen gas released at cathode. It is not first year, second year, third year. Copper only deposited. So at cathode what we are getting? Copper. And at anode, first we should observe the products obtained. Then we can decide H plus or OH minus. At anode, SO4 2 minus. Oxo ion not undergoes oxidation. Instead of this, water undergoes oxidation. Nothing but OH minus. OH minus oxidized to O2. Okay. So at cathode we are getting copper. At anode oxygen. OH minus changed to oxygen. Nothing but H plus left. H plus left in that solution. Okay. H plus left in that solution, because at cathode H2 not released. Okay. Now 1 Faraday gives 1 gram equivalent of copper. Yes or no? It gives 1 gram equivalent of oxygen. Okay. And it gives 1 gram equivalent of H plus, because H plus left. So 1 gram equivalent of copper, 1 gram equivalent of oxygen, 1 gram equivalent of H plus. So here this is 1 Faraday relation. Okay. Now how many Faradays passed? Faradays not given. I given, T given. I into T, it is equal to quantity of electricity. Okay, coulombs. Now it is equal to 96.5 into 10, 965 coulombs electricity passed. 1 Faraday, 96,500 coulombs. Now 965 coulombs passed. How much Faradays? 1 Faraday, 96,500. 965 coulombs passed. Nothing but what is the Faraday? Now it is 965 by 96,500. So it is equal to 10 power minus 2. Okay, 10 power minus 2. Then cancel this one. 10 power minus 2. So how much Faradays passed? 10 power minus 2 Faradays passed. Now see this. 10 power minus 2 Faradays gives 10 power minus 2 gram equivalents of copper, 10 power minus 2 gram equivalents of oxygen, and 10 power minus 2 gram equivalents of H plus. So how much H plus we are getting? 10 power minus 2 gram equivalents. Then what is the normality? Number of gram equivalents by volume in liters. So what is the volume? 1 liter. Okay. So now what is the concentration? Normality concentration or molarity concentration? H plus only no. So what is the concentration? 10 power minus 2. So concentration 10 power minus 2. Now pH. So what is the pH? pH is equal to minus log H plus concentration minus log base 10 power minus 2. So it is equal to 2 log 10. Nothing but to 2 into 1. So 2. So what is the pH? 2. Okay. Like this we should solve the pH problems. First observe what are the products obtained. Nothing but electrolysis. Definitely pH problem means aqueous solution only. In that aqueous solution H2 released at cathode or not. OH oxygen released at anode or not. H2 released OH minus present. Oxygen released H plus present. Both released no H plus no OH minus. Nothing but the solution is a neutral solution. Okay. First products obtained we have to observe, then calculate. So what is the relation here? 1 Faraday gives 1 gram equivalent of H plus or OH minus. Based on that we can solve. Okay. So come to the next problem. See this third problem. What is the amount of aluminum deposited on the electrolysis of molten Al2O3 when a current of 9.65 amperes is passed for 10 seconds? Current 9.65 amperes given and time 10 seconds given. What is the amount of aluminum? Amount of aluminum they are asking. Okay. So amount of aluminum obtained. So using W is equal to E into I into T by 96,500 we can use. Otherwise direct how to solve this one? Amount of aluminum formed from Al to O3. Nothing but Al plus 3 changes to Al. Anyhow we learned that 1 Faraday gives how much aluminum? 9 grams of aluminum. Yes or no? In that list we learned 1 Faraday 9 grams of aluminum because 1 gram equivalent of aluminum. So anyhow like this also we can learn. We can solve this up. So 3 plus 3, nothing but 3 electrons. 3 Faradays gives 27 grams. 3 Faradays gives 27 grams. So 1 Faraday gives 9 grams. Now here how many Faradays? Okay. So how much quantity of electricity we are passing? Current I given and T given. Okay. I 9.65 into T 10. Nothing but it is the 96.5 coulombs electricity passed. Okay, 96.5 coulombs electricity passed. Nothing but how many Faradays? 1 Faraday 96,500. 1 Faraday 96,500. 96.5 coulombs means how much Faradays? So 96.5 by 96,500. Okay, 96.5 by 96,500. It is equal to 10 power minus 3. Okay, 10 power minus 3 Faradays passed. 1 Faraday gives 9 grams. 10 power minus 3 Faradays gives how much? 9 into 10 power minus 3 grams. Okay, 9 into 10 power minus 3 grams of aluminum deposited when 9.65 amperes electricity for 10 seconds passed. So amount of substance deposited is directly proportional to quantity of electricity passed. So this much electricity only we passed. That's why how much obtained? 9 into 10 power minus 3. If 3 Faradays passed, 27 grams we will get. But passed just 10 power minus 3 Faradays. So how much we are getting? 9 into 10 power minus 3. Otherwise direct how to solve? Like this we can solve. Otherwise if you want to use that formula only, W is equal to E. Equivalent mass of this aluminum. E into I into T by 96,500. Okay. So W is equal to equivalent mass. What is the equivalent mass of aluminum? Aluminum atomic mass 27. Equivalent mass 9. 9 into I 9.65 into T 10 seconds. Definitely this one in seconds only we have to take by 96,500. Okay, 96,500. So anyhow we are getting same answer. W is equal to 9 into 10 power minus 3. So you can use this formula. Otherwise 1 Faraday without using pen and paper how to solve. 1 Faraday 9 grams. Now here 9.65 into 10 96.5 Faradays. Definitely 10 power minus 3 Faradays. 10 power minus 3 Faradays how much will give 9 into 10 power minus 3. Okay. So 1 equivalent and 10 power minus 3, 10 power minus 3 equivalents. Nothing but 9 into 10 power minus 3. Okay, this is the amount of aluminum deposited. So come to the next problem. The electrolysis of 7.2 liters aqueous solution of copper sulfate. A current of 9.65 amperes passed for 2 hours. Hours given, we should convert into seconds. Okay. Calculate the weight of copper deposited at cathode and calculate the volume of oxygen produced at anode at STP Anyhow, 22.4 liters. Using that only, calculate the pH of the solution after electrolysis. Calculate the amount of copper deposited, calculate the volume of oxygen released, calculate the pH of the solution. Okay. Now, pH also they are asking. Better this problem like this. 1 Faraday, 1 gram equivalent of now copper sulfate during electrolysis. Copper deposited cathode or hydrogen released at cathode, copper deposit. So 1 gram equivalent of copper deposited. Okay. At anode, SO4 2 minus undergoes oxidation or OH minus undergoes oxidation. OH oxidizes to oxygen. Nothing but 1 gram equivalent of oxygen releases. Next, then OH minus consumed, but here H plus left. H plus left means it is a 1 gram equivalent of H plus. Okay, 1 Faraday produces 1 gram equivalent of copper, 1 gram equivalent of oxygen, 1 gram equivalent of H plus, because it is a aqueous copper sulfate solution. Okay, 1 gram equivalent of H plus. Now 1 Faraday produces this. Now how many Faradays given? See this. I 9.65 at time of 2 hours. Nothing but 2 into 3600 seconds. Okay, now it is a Faradays. How much Faradays we have to find? I value 9.65 into 2 into 3600. Okay, this is the quantity of electricity passed. Now 96,500 is the coulombs. 96,500 coulombs 1 Faraday. Now this is how much Faraday? It is equal to, this is a 1 Faraday. Okay, how much Faraday we are getting? Now it is equal to this one by 9.65 into 2 into 3600. Nothing but it is 72. 7200. Okay, 7200 by 96,500. Okay, 96,500. So it is nothing but 0.72. Okay, this one cancel out. 0.72. So how much Faradays passed? 0.72 Faradays. Now here first converting to Faradays. I given, T given. Convert this hours to seconds. Then coulombs quantity of electricity we are getting. Convert that into Faraday. 1 Faraday 96,500 coulombs. Then how many Faradays? 0.72 Faradays. Now what is the relation? Now come to this. Okay. 0.72 Faraday gives 0.72 equivalent of copper, 0.72 equivalent of oxygen, 0.72 equivalent of H plus, gram equivalents of H plus. Okay. Now here this mass first they are asking. First one, calculate the mass. Now 0.72 gram equivalents of copper we are getting. Okay, what is the mass? Number of gram equivalents is equal to mass by equivalent mass. Yes or no? Mass by equivalent mass. Now mass is equal to number of equivalents. How much? 0.72 into its equivalent mass, copper equivalent mass 31.7. Okay, if you simplify this, this is the mass in grams. Otherwise, this how we can solve? Mass of copper only, mass of copper. W is equal to equivalent mass 31.7 into I 9.65 into T 2 into 3600 by 96,500. Nothing but it is a E into I into T by 96,500. Using this formula also we can find the mass. Okay, like this we can find, or just we are finding first Faradays because they are asking pH also no. That's why this method better. First Faradays. How many Faradays we are getting? 1 Faraday, 1 equivalent. So 0.72 Faradays. Like this method only better. 0.72 gram equivalents we are getting. Gram equivalents we are getting mass. Mass by equivalent mass. So this is the grams of copper. So how much amount of copper deposited? Now second one, calculate the volume of oxygen. Follow this method or direct formula. Okay, this is the mass of the copper deposited. Now what is the volume of oxygen? Gram equivalents. Equivalents of oxygen. Volume of oxygen means we learn one more. 1 Faraday gives 5.6 liters of oxygen. Yes or no? 5.6 liters of oxygen. Instead of this, we can use this relation. This is better because at STP only they are asking 1 Faraday 5.6 liters. Now 0.72 Faradays, how much volume? Okay, 1 Faraday 5.6 liters, 0.72 Faradays we are passing. Now what is the volume of the oxygen? So volume of oxygen is equal to 0.72 into 5.6. 0.72 into 5.6 liters. It is the volume of oxygen. Okay, like this easy to solve. Otherwise, what we can do? Formula only if you want to apply. Now, W1 by W2 is equal to E1 by E2. Okay, Faraday's second law. Because same quantity of electricity we are passing, copper and oxygen. Copper deposited we are getting W1. First simplify this. You will get W1. Okay, this is the copper. And oxygen we want. Then equivalent mass of copper 31.7. Okay. Equivalent mass of oxygen. What is the molecular mass of this oxygen? O2. 32. So equivalent mass by 4 8. Okay. By 4 8. So 31.7 by 8. We know this mass of copper. We have to find the mass of oxygen. First calculate the mass of oxygen. Then 32 grams of oxygen means 22.4 liters. Now this mass of oxygen, how many liters? Like this also we can solve. But better is 1 Faraday gives, we can save the time. 1 Faraday gives 5.6 liters of oxygen. Now 0.72 Faradays gives how much oxygen? That's it. That's the volume of oxygen. Now come to this third one. pH of the solution. pH of the solution. What formed here? H plus formed. H plus. How much? 0.72 gram equivalents. 0.72 gram equivalents of H plus form is, what is the concentration of H plus? Normality. Number of gram equivalents by volume. Yes or no? Number of gram equivalents 0.72. By volume how much given? 7.2. Okay. Volume 7.2 given. Nothing but it is 0.1. 0.1. 10 power minus 1. So H plus concentration is equal to 10 power minus 1. Now pH is equal to minus log base 10 H plus concentration. Minus log base 10 10 power minus 1. So it is equal to 1. So pH is equal to 1. So first one, W is equal to E into I into T by 96,500. Like that you can solve. Otherwise first found the find that Faradays. Okay, first find the Faradays. How many Faradays passed? Then from that use this link calculate. Okay. Next one is calculate the volume of oxygen. Volume of oxygen. 1 Faraday 5.6 liters of oxygen. Then this Faradays how much oxygen? And for this pH just gram equivalents how much we are getting. Okay. From that we can calculate the pH. This is about the fourth problem. So now come to the fifth problem. So this fifth problem, what is the volume of oxygen liberated at anode at STP in the electrolysis of cadmium sulfate solution when a current of 2 amperes is passed for 8 minutes? Oxygen liberated they are asking. It is the aqueous solution definitely because oxygen they are asking. So cadmium sulfate during electrolysis, cadmium at cathode not hydrogen, and SO4 2 minus undergoes oxidation. No, instead of this SO4 2 minus, OH minus undergoes oxidation, releases oxygen. That volume of oxygen only they are asking. Okay. Now here 1 Faraday 1 gram equivalent of cadmium, 1 gram equivalent of oxygen. This not required. Just volume only they are asking. No. So here 1 Faraday gives 5.6 liters of oxygen. Yes or no? 1 Faraday releases 5.6 liters of oxygen. This relation is better one. So now here, how many Faradays first identify? How to calculate the number of Faradays? Number of Faradays is equal to I into T. It is the coulombs, quantity of electricity, by 96,500. Okay, I into, direct like this we can solve. How many Faradays we are getting? I into T by 96,500. I 2 amperes. T in seconds, minutes given 8 into 60. Okay, 8 into 60 by 96,500. Okay, now it is 96 by 96,500. Okay, 96,500. Nothing but it is nearly 0.009. So 0.01. Can we use like this? 0.01. Can we take Nearly 0.9 we are getting 0.01. So now it is a Faradays. How much Faradays? 10 power minus 2 Faradays. Okay. 1 Faraday gives 5.6. 10 power minus 2 Faradays gives how much? 0.01 Faradays gives how much? It is equal to 5.6 into 10 power minus 2. Okay. 5.6 into 10 power minus 2 means 0.056. 0.056 liters of oxygen we are getting. Just very simple. 1 Faraday, 5.6 liters of oxygen. 10 power minus 2 Faradays, how much? 5.6 into 10 power minus 2. Okay. So now come to the next problem. Marshall's acid is prepared, H2S2O8. Marshall's acid is prepared, it is a peroxo disulfuric acid by the electrolysis of H2SO4 as 2H2S4 gives H2S2O8 plus 2H plus 2 electrons. O2 gas and H2 gas are obtained as byproducts. In such electrolysis, 4.48 liters of H2 and 1.12 liters of oxygen were produced at STP. The weight of H2S2O8 formed is weight of Marshall acid they are asking. So here, see this reaction H2S4 changes to H2S2O8 plus H2 because 2H plus 2 electrons, H2 gas. So now here the given reaction 2H2SO4 gives H2S2O8 plus H2. Okay. Nothing but number of moles of H2 formed, that is equal to number of moles of this Marshall acid. Number of moles of Marshall acid. Number of moles of H2 formed, not only this reaction, along with this oxygen also released. Nothing but H2O changes to H2 plus O2. H2 plus O2. Okay, like this we are getting. So H2O gives H2 plus O2. Hydrogen released and oxygen released. Now here hydrogen we are getting from water and also from this sulfuric acid. Oxygen we are getting from water and Marshall acid from sulfuric acid. The number of moles of hydrogen from sulfuric acid, that is equal to number of moles of Marshall acid produced. But total number of moles of hydrogen not equal. Okay, not equal to this one because here also we are getting hydrogen gas. So this total volume what we are getting, that is from H2O and also from H2SO4. Now like this volume of hydrogen and oxygen given, then what we can do? Instead of number of moles, now use the gram equivalents. See this, here we are getting and here also the number of gram equivalents of hydrogen obtained, that is equal to number of gram equivalents of oxygen. The number of gram equivalents of hydrogen obtained, that is equal to number of gram equivalents of this Marshall acid. So total number of gram equivalents of hydrogen obtained, that is equal to oxygen plus Marshall acid. So here what we have to use? The number of equivalents. Number of equivalents of hydrogen is equal to number of equivalents of oxygen plus number of equivalents of H2S2O8. Only this reaction given direct. Number of moles of H2 is equal to number of moles of Marshall acid. But both combined with oxygen also mentioned, no? That's why we have to use equivalents. So what is that? Number of equivalents of hydrogen, that is equal to number of equivalents of oxygen plus number of equivalents of this Marshall acid. Now, how many equivalents of hydrogen released? Now, 1 Faraday gives 1 equivalent of hydrogen. Yes or no? 1 Faraday gives 11.2 liters of hydrogen. 11.2 liters means 1 equivalent. So now here we can use 11.2 liters. 1 equivalent. So what we are using in this? 11.2 liters hydrogen, that is equal to 1 equivalent. Okay. 4.48 liters hydrogen. How many equivalents? 4.48 by 11.2. Okay. This is nearly equal to 0.4. 0.4 equivalents. Then oxygen. How much oxygen? Now see that 1 Faraday gives 1 equivalent of oxygen. Yes or no? 1 Faraday, already we learned this one. 1 Faraday gives 5.6 liters of oxygen. 5.6 liters of oxygen. Nothing but 1 equivalent, that is equal to 5.6 liters of oxygen. 5.6 liters of oxygen. Now here 1.12 liters. 1.12 liters of oxygen means how many equivalents? 1.12 liters. 1.12 by 5.6 is equal to 0.2. Okay, 0.2. So here the number of equivalents of hydrogen 0.4. The number of equivalents of oxygen 0.2. What is the number of equivalents of H2S2O8? The number of equivalents of H2S2O8. What is the relation? Number of equivalents of H2 equal to number of equivalents of O2 plus number of equivalents of H2SO4. So H2SO4 is equal, this minus this, nothing but it is equal to 0.4 minus 0.2. 0.2 equivalents. So number of equivalents of H2SO8 0.2. Now mass they are asking. What is the formula? Mass. Number of equivalents is equal to mass by equivalent mass. Mass is equal to number of equivalents 0.2 into equivalent mass of H2S2O8. Hydrogen 1 and sulfur 32 and oxygen 16. So if you add 194 is the molecular mass. Then equivalent mass 97. Okay, 97. Yes or no equivalent mass? Because the S2O8 2 minus. So equivalent. Others two replaceable hydrogens. Equivalent mass is equal to 97. So 0.2 into 97 is the mass of H2S2O8 formed. Graphs. Okay. So what we should do, just one point here, the number of equivalents of during this process, the number of equivalents of hydrogen that is equal to number of equivalents of oxygen plus number of equivalents of Marshall acid produced. So first find the number of equivalents of hydrogen. One equivalent 11.2 liters. So 4.48, how many equivalents? 0.4 we are getting. And one equivalent 5.6 liters of oxygen. 1.12 liters means how many? 0.2 equivalents. This is equal to sum of these two. So 0.4 equal to 0.2 minus H2S2O8. So H2S2O8 we are getting 0.2. Number of equivalents. Then formula mass by equivalent mass. Mass is equal to 0.2 into 97. Okay. So now come to the next problem. Chromium metal can be plated out from an acidic solution containing CrO3 according to the following reaction. What is the reaction? CrO3 plus 6H plus 6 electrons gives chromium plus 3H2O. Cr plus 3H2O. How many grams of chromium will be plated out by 24,000 coulombs electricity? 24,000 coulombs we are passing. Then how much chromium will deposit? The amount of chromium deposit. Amount of chromium. Just weight of chromium they are asking. So now here 24,000 coulombs. Now see this reaction. 6 electrons we are using for this 1 mole chromium. To deposit 1 mole chromium, how many electrons required? 6 electrons. Nothing but 6 Faraday. 6 Faraday deposits 1 mole chromium. Okay. 1 mole chromium is molecular mass, atomic mass, chromium atom, atomic mass 52 grams. Chromium atomic mass 52 grams. So 6 Faradays deposits 52 grams of chromium. Now how many Faradays this one? Number of Faradays is equal to Q by I into T by 96,500. Okay, 24,000 by 96,500. Now it is nearly 0.24. Okay, nearly it is a 0.24 Faradays. So 6 Faradays 52 grams. 0.24 Faradays how many grams? Okay, what is the mass of chromium? So it is equal to 0.24 into 52 by 6. 0.24 into 52 by 6. Simplify this one, you will get nearly 2.15 grams. So the mass of chromium deposited, that is equal to 2.15 grams. Just here one reaction given. In that reaction 6 electrons involved. Nothing but 6 Faradays. 6 Faradays produces how much chromium? 1 mole chromium. 6 Faradays 1 mole chromium. To deposit 1 mole chromium, 6 Faradays required. 1 mole means it's the atomic mass 52 grams. So 6 Faradays passed, then 52 grams deposit. So amount deposit is directly proportional to quantity of electricity passed. Okay. Now here 24,000 coulombs given. Convert into Faradays. 0.24 Faradays. Now 0.24 Faraday's deposits how much amount of substance? So what we are getting? 2.15. Okay. So now come to the next problem. Eighth problem. What amount of work in joules is needed to move an electron against a potential difference of 1 volt? Volts given. What amount of work is needed to do the same for 1 mole of electrons? For 1 mole of electron also they are asking. Work in joules. Work in joules. It is equal to volts into quantity of electricity? Yes or no? Volts into quantity of electricity. How much volts? 1 into coulombs. Coulombs, quantity of electricity. One electron charge in coulombs. One electron charge how much? 1.602 into 10 power minus 19 coulombs. Yes or no? 1.60 into 10 power minus 19 coulombs. Nothing but what is the quantity of electricity in coulombs? 1.602 into 10 power minus 19. So, 1 electron work, electrical work done, 1 electron work in joules, that is equal to 1.602 into 10 power minus 19 joules. Nothing but this is the work. Okay, 1.602 because 1 volt only passed. So, 1.602 into 10 power minus 19 joules. This is for 1 electron. 1 mole electron how much? 1 mole electron. 1 mole electron is 1.602 into 10 power minus 19 into Avogadro number 6.023 into 10 power 23. So if you multiply this, nearly will get 96,500. Nothing but it is a Faraday. Okay, 1 Faraday. So 1.602 into 10 power minus 19 into 6.023 to 10 power 23. This is for 1 mole work. Okay, in joules, 96,500 joules. This is nothing but 1 Faraday. Okay. It is the calculation of work in joules if quantity of electricity given and volts given, voltage given. How to calculate? Okay. Next, come to the next problem. Ninth problem. Electrolysis of a solution of MnO2 in aqueous H2S4, acidic medium H2S4 is a method for the preparation of MnO2. MnO2 preparation. As per the reaction, Mn plus 2 plus H2O gives MnO2 plus H plus H2. Okay. Passing a current of 27 amperes for 24 hours gives 1 kg of MnO2. What is the value of current efficiency? So this is the problem related to current efficiency. So what is the value of current efficiency? Molecular mass of MnO2 87 given. So how to calculate this current efficiency? So see that first ampere current given and hours given, time also given. So first calculate the amount of this amount we are getting, but originally same answer we are getting or not, we have to check. Okay. So what is the Faraday's first law? W is equal to E into I into T by 96,500. Okay, we know equivalent mass, I given, T given, W also given. Then what we should find? This W only we are finding. Because here 1 kg given. Same 1 kg we are getting or not. Because problem is a current efficiency. Once again we have to check that 1 kg we are getting 100% efficiency there. 1 kg we are not getting any other getting. Then 100% efficiency not there. So how to find this? So first calculate the mass, E into I. What is this E value? Molecular mass 87. Equivalent mass, see this, Mn plus 2 changes to Mn plus 4. Nothing but 2 electrons. Equivalent mass is equal to 87 by 2. Okay, 87 by 2. So now here it is a, okay, 43.5 into I value 27 into 24 hours, 3600 seconds by 96,500. 96,500. So you simplify this one, nearly 1051.5 like this. Okay, nearly you will get this value 1051.5. This is the weight. But here what is the given weight? 1 kg. 1 kg means it is in grams now. Okay, because we are using equivalent mass like this. Okay, now 1051 grams we are getting. Here 1000 grams only. Here this one produce 1000 grams. So the current efficiency. Now current efficiency, it is equal to amount obtained. Nothing but this we are calculating 100% efficiency there. How much we are getting? Like this. What we are getting? Here we are imagining 100% efficiency there. 100% efficiency like this, but we are getting that only. Nothing but how much amount, actual amount we are getting by, if 100% there, how much we are getting into 100. Okay, this is the current efficiency. Okay? 95.0%. Okay, current efficiency. Simplify this, you will get the answer as the current efficiency. Okay. So this is the calculation of current efficiency. How to calculate? They will give anyhow how much amount produced, but again we have to calculate. Same we are getting 100% efficiency there. Same we are not getting. Then how to find the current efficiency? Current efficiency is equal to actual what we are getting by, if 100% there, how much we can get into 100. Okay, 95.0 nearly we are getting. This is a percentage of current efficiency. Okay, this is the calculation of current efficiency. Now come to the next problem. Last problem. Calculate the number of Faradays required to electrolyze 6.35 grams of Cu plus aqueous from an aqueous solution. Okay, for the electrolysis of 6.35 grams of Cu plus. So Cu plus changes to Cu. How many electrons required? Plus 1 charge, 1 electron. Nothing but for this 1 Faraday required. 1 electron means 1 Faraday. 1 Faraday gives 1 Cu, 1 mole Cu. 1 mole Cu means what is its molecular atomic mass? 1 Faraday atomic mass. Okay, 1 mole Cu. Atomic mass 63.5. Okay, 1 Faraday gives 63.5 grams of Cu. So how much grams we get? 6.35 grams. Cu plus 1 electron gives Cu. 1 electron means 1 Faraday. If 1 Faraday passed, then 1 mole copper will deposit. 1 mole copper deposited means 63.5 grams deposited. 1 Faraday passed, then 63.5 grams will deposit. Now for 6.35 grams, how much Faraday is required? Okay. So now it is equal to 6.35 by 63.5. It is equal to 0.1 Faraday. So what is the answer? 0.1 Faraday. So this is about the problems related to Faraday's laws. Okay. So to practice more problems, anyhow in description I given practice sheet with solutions. So you download that and practice. Okay. Thank you.